some vocab before we really dive into things. Supplementary angles are angles that have a sum of what? Close. 180. Very good. They have a sum of 180 degrees. What does sum mean?
Yes.
Let's add to. Yeah. So there's angles that add to 180 degrees. They are supplementary. What about complementary angles? They add to what? 90. Good. Complementary angles add to 90 degrees. Supplementary add to 180. Complementary add to 90. So sometimes you might be told these two angles are supplementary. Find x. Well, if you know what supplementary is, then you know how to set up the equation to solve. Okay, that's where the vocab comes in handy. Adjacent. When you hear the word adjacent, what does that mean?
I don't know.
Don't know? What, Deborah? Next to, yeah, right next to. So, if you know that word adjacent angles are angles that are just right next to each other. Okay, that's it. There's two angles next to each other. They don't overlap though. So we look at this diagram here. Angle ABD, or ADB, sorry, is right next to angle CDB. They're right next to each other. If you notice, they share a side. And they have a common side. They are adjacent. Angle. So you can highlight it or write it down here. Angle ADB, yellow angle. And angle CDB. Two angles that are right next to each other. They share a side. Share that middle equal there. And a postulate is a statement that is accepted true without proof. Meaning it's kind of like a no-brainer. Like, we are in geometry class right now. Is there any argument against that we're not in geometry class? We really agree that we're in geometry class, or we know we're, like, right? We know we're in geometry class. That is a postulate. You don't really have to argue much, or if at all. It's just kind of like, yeah, that's true. I can't argue against that. Right? Which, knowing that definition, leads us to our first postulate. And that is the angle addition postulate. Okay? Essentially, what that formal definition is saying is that if you have two adjacent angles, so this angle right here, I'm the highlighter. QSR, okay, is adjacent to what angle? What angle right next to QSR? Or QR, what is that, T? Sorry, that was QRT, that green angle. What angle is adjacent to it? SRT. These two angles, the green and the yellow angle, are adjacent. Which means when you add them together, it equals the entire big angle. That's what the angle addition postulate means, right? If we add the two little things together, it's going to equal the big thing. That's why it's a postulate. Okay. You don't really have to do any work to prove it. So, when we add the two little angles together, what do we get when we do 40 plus 83? I kind of accidentally got covered up. 40 plus 83 is what? 123. That means the measure of this big angle is 123 degrees. That's what the angle addition postulate is. Add the two little angles together and it equals the big angle. Questions over that? So if we take a look here at some examples, we want to use the angle addition postulate to find this big angle with a given angle. So we want to find angle T and F. So using that angle addition postulate, you add the two little angles together and it will equal the big. So what do we get when we add those two little angles together? 90. Good. So the measure of the big angle is 90 degrees. Add the two little angles together, it equals the big. No, if it said, like, how would you describe them? Yes. But they wanted to know the measures. Yeah, but you are very good. These are examples of complementary angles because they add to 90 degrees. Good. Right? You want to find the angle XLV. Well, what do we have to do with 39 and 103 to find that angle? Add them. That angle addition postulate. Well, what do we get when we do 39 plus 103? 42. So the measure of the big angle, this whole angle, is 142 degrees. If we take a look at C, we want to find angle QRT. And again, what do we have to do with the little angles to find the big angle? Add them. Right? And we add them, 15 plus 30 is what? So the measure of this angle right here is 45 degrees. Well, questions over those three. Not too bad. Add the little pieces to get the big. If we take a look at this one, it says using the angle addition postulate, find the value of the missing variable. Now you have to be very, very, very careful. I see this a lot. In the directions, did it say that BC was an angle bisector? Does it say BC is an angle bisector? Good. Okay. So can we set those two angles equal to each other? Stop. Wait. What do you think we need to do? Yeah, you got it. Very good. In the directions, it said use the angle addition postulate. But these are going to be added angles. And as Lucas said, what you're going to do is you take the two little angles, add them together, and set them equal to the big angle. So the big angle equals 100 degrees. So we're going to set them equal to 100. Can't set them equal. That indicates that they are equal. We're given a bisector. We don't know that that's a bisector. We won't hold it. I see that as time, so be very careful. Okay? I'm going to use that angle addition postulate. Very good, Lucas. So in order to solve, what do we have to do with our terms first? Combine them. So we combine our like terms. 4x plus 3x is what? X. Got out 2 minus 7 is negative. After you combine your like terms, it's just this two-step equation. Add the 5. Get 105. Divide by 7. So 105 divided by 7. So x is equal to 2. Look at the next one. Again, we're using the angle addition postulate. We know the big angle, MRW, is 90 degrees. We want to find x. Right? What do we have to do with two little angles? We're using the angle addition postulate. What do we do for two little angles? Add them. Good. Add them together and set them equal to. Add the little ones. And then you can solve. When we solve, again, what do we have to do first? Do that 3x plus x is 4x. 4x is equal to 84. 4. So x is equal to 84 divided by 4. Very good. Questions over that? Not too bad. Now we add angles. Segments and sides. Really the only thing you can do with them is set them equal. So when you're given segments or sides for shape and you're trying to find x, set them equal. Angles, you do a lot of different things. Set them equal to, add them and set them equal to another angle. Set them equal to each other. Set them equal to 90. Things like that. Not things you can do with angles. Not much you can do with sides or segments. You have to think a little bit more of angles. So take a look at the next example. Example 3 says, using this diagram right here, we're going to answer the following. So we want to use the angle addition postulate to write the equation for angle AO, way off, A or COA. COA. Correct? There you go. A little off there. COA. Well, what type of angle is angle? Straight lines, we call what type of angle? Straight angle, okay? So we're going to figure out what two angles are making a straight angle. If I look here, I have angle COB is one of them. What's the other angle that's making that? What is it? No, what is the name of that? It is not two things, but you're right. No, like how would you name it using your points or a number? What is it? BOA. BOA. Still off. BOA. There we go. There we go. That those two angles make up that straight angle. To visualize, like, because it is kind of confusing. It's like we had an angle like this, okay? And then we just took the sides and flattened them out to make a straight line. That's more visually, makes more sense. We had an angle like this, and we just flattened it like that. Makes more sense. That's why you can still have angles that form a straight angle. Okay. So to write the equation, I'm going to take this angle right here, angle 1, and add it to the other angle, angle 2, and it's going to equal the whole big angle, which is angle COA. Add those angles together. Angle 1 plus angle 2 is going to equal angle COA. This angle plus this angle equals the full angle. So we take a look at B. If angle 1 is equal to 4x plus 20, and angle 2 is equal to 100, find the value of x. Well, I know to get COA, I know I can add these two together. So I'm going to add angle 1 to angle 2, and it equals COA. But what did he say COA was? What type of angle? Straight angle. What do straight angles equal? So we're going to set it equal to 180. These two angles add to 180 degrees because they make a straight angle. So now we just solve for x. What do we have to do first when solving? Combine our like terms. We combine our like terms. We combine the 20 and the 100. What do we get? And now again, it's just your general two-step equation. Put 120 over. We get what's 180 minus 120? And then divide by 4. 60 divided by 4 is what? Questions over that. So look at example 4, same kind of thing. We have a different diagram. We're going to use the angle addition postulate to write an equation for an angle. Our board's not isn't A, B, C. Well, how can we write that equation? What are the two angles that are making up angle ABC? It is a straight angle. What two angles are making up that angle? Yeah, ABB. ABB and CB. Those two angles are making up that straight angle. Okay? So if we add those two angles together, if I add angle 2 to angle 1, it's going to equal the whole thing, which is ABC. This angle plus this angle equals the whole angle. Again, it's just a flexed out angle. Okay. So, similar to what we did last time, if the measure of angle 2 is 6x minus 15 and angle 1 equals 45, find the value of x. So I'm going to do add the two angles together. So angle 2 plus angle 1 is equal to what? What did we said ABC was a straight angle, and what do straight angles equal? So this is going to equal 180. And then we solve. So when we solve, again, combine your left terms. We combine them. Negative 15 plus 45 is what? Move the 30 over. 180 minus 30 is? We get 50? 150? Divide by 6. So we divide by 6, x is equal to what? So from examples 3 and 4, it seems that adjacent angles, so angles that are right next to each other, that form a straight angle will always add to what? 180. Okay. There are a special, or these, or okay, there is a special name for these type of angles. So adjacent angles, angles right next to each other, that form a straight angle, are what we call linear pair angles. And there are a pair of angles that make a straight line, linear pair. What we discovered in example 3 and 4 leads us to our first theorem in geometry. Unlike a postulate, a theorem is a fact that needs to be proven true. So postulate is just kind of one of those no-brainer things. You don't really have to argue for the truth. It's kind of obvious that it is. A theorem theorems, someone made that statement, and then had to back it up with text and math. Okay? So we are going to talk about informally that proof. Okay? Let's talk about the formal proof later on here. But essentially what the linear pair theorem says is that if two angles form a linear pair, then they are supplementary. Supplementary means what again? Adds to one angle. Okay. So two angles form a linear pair. They add to 180 degrees. So angle 1 plus angle 2 equals 180. They add together to make a linear pair. Just like you discovered in example 3 and 2. So here it's kind of the informal argument that they made. I'm going to cut and paste it over. We can use that diagram. We're using that diagram in the top box. Okay. So because the angle addition postulate, we know angle 1 plus angle 2 equals what big angle? What is it? Well, what is the name of that angle? ABC. Okay? So this is the argument that they made. So when they were like, hey, this is true. These angles always add to 180, and someone's like, prove it. I don't believe it. You need to prove that to me. This is the argument that they made. Okay? They said, well, if you look at this diagram here, angle 1 plus angle 2 equals that whole angle, angle ABC. Then they said, we also know that ABC is what type of angle? Straight angle. So because it's a straight angle, it equals what? 180 degrees. So what we could do is take 180 and plug it into this equation for angle ABC to get angle 1 plus angle 2. That's the argument that they make informal. There's a much more formal argument. We're not going to get into that right now. We're focusing on this. But if you just know angle addition postulate, when you're making a straight angle, angle will always equal 180. Those angles will always add to 180 degrees. They'll always be supplementary. Questions over that? So we take a look at example 5. It says KPL and JPL are linear pair. Find X and the measure of angle KPL. Well, this is a great vocab word. It told you what type of angles they were. So if they are a linear pair, what are these two angles going to add to? So we're going to add them together. And separate. And then so. Instead of equal, you weren't told it was a bisector. They're a linear pair. So we know they add 180 degrees. They're right next to each other, and they make a straight angle. So when we solve, what do we have to do first? When we combine our like terms, 2x plus 4x is 6x. 24 plus 36 is 60. To get x by itself, move the 60 over. Divide by 6. And 120 divided by 6, x equals what? That's it. Are we done? Or not? What do we have left to do? Good. We have to find KPL. Very good. Read those directions. I do it myself. My own worksheet. But I make. I solve for x and then forget to plug it in my game. It happens. Just make sure you double check those directions. How do we find KPL? We want to find this angle right here, this blue angle. I'm highlighting KPL. And we know x is 20. What can we do with 20? Let's see. Yeah. Very good. Plug 20 in 4x. Measure of the angle. You don't have to put the n there. It's equal to 2 times 20. plus 24. And what do we get when we do 2 times 20 plus 24? So KPL is 2.3. Well, if we know KPL is 64, and we know these two angles add to 180 degrees, what can we do to find LPJ? Mark? Yeah, I like the second one. I like the 180 minus 64. Less work. I like to do less work. Okay? So another way, if you're given one angle and you want to find the other one and you know they're a linear pair, you can just do 180 minus 64. And what do we get when we do 180 minus 64? 160. So we know this angle is 160. Okay, little cycle. So take a look at this last one. We want to find the value of the missing variables in the diagram, and in this case we have two. We have x and we have y. Don't write this down what I'm about to write down. Just watch. But all the linear pairs we've been dealing with, you notice I see a straight line right here. And this angle make that straight line. Okay? So these two angles, what do they add to? 180. Right? But when I add them together, again, don't write this down. What's the problem here when I add these angles together and set them equal to 180? We have x and y. So that can get us anywhere. No. So when this happens, it's going to happen a lot in geometry. We have x and y in the entire diagram. You have to make sure x pairs up with x and y pairs up with y. So if we look here back in our diagram, I notice this angle. This is also a straight angle. Okay. Going up and down, but it's still a straight angle, right? This angle right here. This angle right here makes out that straight angle. So what does 3x plus 5 and x plus 15 add up to? 180. Yeah, it's going up and down, but it's still a straight line. It's still a straight angle. They still are going to add to 180 degrees. I just do 3x plus 5 plus x plus 15 and set it equal to 180. So again, when we solve, what do we have to do? What terms? We get 4x. Right here to get 20. And then again, it's a nice little two-step equation. Move the 20 over. Divide by 4. 160 divided by 4 is what? What is it? What is it? 40. From here. So again, if you look at that diagram, I have this angle right here, and I have this angle right here, again, both making a straight angle. So what does y plus 20 and 4y minus 15 add up to? 180. If you make a straight angle, they're going to add to 180 degrees. And again, we just combine our like terms. Get 5y plus 5. 5 over. Divide by 5. And y ends up equaling what?
175 divided by 5. Jordan?
Wait.
I think you get the answer there.
35. Oh, you're right. So the big takeaway, two angles form a straight angle. They are called linear pair angles, and they are supplementary. They will add 180 degrees. Questions over that? Look, your paper